We are now in the southwestern Bluewing Mountains on the northern contact of the Sahwave batholith with the surrounding metamorphic rocks. So just to get you oriented here, over there is the northern Sahwave range. So that would be and there's, well actually that's not Juniper Pass. Juniper Pass is the next one over, but that would be the Granite of Juniper Pass, and then the further high part would be Granite of Bob Spring. These hills are at least capped by tertiary volcanics. I think one of them has bedrock underneath, or basement I mean. If we pan over this way, you can now see the north end of the Nightingale Range. Actually no, sorry, take the back. That's the Lake Range actually. The Nightingale Range is eclipsed by this. You can just see the north end of the Nightingale Range back there. That's the Lake Range with snow on it. And then these jaggedy snow mountains is the Selenite Range. The high peak there is Comiva Peak, and then we have Mount Limbo and Purgatory Peak over on the left, with fun names here. Anyway, the reason we're here is because we're right at the northern edge of the Sahwave batholith. Here's something that's basically the Granite of Juniper Pass. Here it's a little fine grain because we're right at the margin. And then if we just go a few inches over this way, we start getting xenoliths of this sort of schisty material, which are the metamorphic ball rocks. And the outcrop here isn't quite continuous, but then you can start seeing there's more outcrops of this sort of hornblende, hornfels rock. That's, you know, the protolith is probably a quartzo-feldspathic, quartz and feldspar rich siltstone or something like that. It doesn't make very pretty metamorphic minerals. It's, you know, it's got some micas in it. Otherwise it's mostly quartz and feldspar, so it's not the most attractive rock, but the outlying sign group doesn't tend to metamorphose to anything super exciting. Now from here, the story here is really about the nature of this contact. And so the contact here is here, and then it sort of snakes up this hill. So you can see that all these dark things are the metamorphic rocks, and the light rocks are the granitoids. So the contact snakes up north of that boulder sticking up there, and it snakes up onto the ridge over there, and then it snakes back over here. You can see, again, there's a contact between the granite and the metamorphic. In fact, you can see the granites come out into a little point there, and then there's more metamorphics above it. So this contact snakes back and forth all up and down this hill. You know, generally speaking, I don't know, the contact doesn't really follow a straight line at all here, but, you know, generally the direction we're moving right now is, I guess it would be northeast, or generally northish, let's just say. So here's a place where we can put our finger on the contact. So Granite of Juniper Pass, metamorphic rocks, nice sharp contacts, maybe a little bit of melting or mingling or something going on here because there's this weird streak coming off of it. Complicated xenoliths and things like that. Here you can see a little xenolith peak that's surrounded by, at least it's surrounded by granite on the bottom. Probably it was around the top too. So there's pretty clear evidence of stoping going on here, little xenoliths breaking off. And to some extent that's just suggested by the very complicated outcrop pattern of the contact. So, you know, it zigzags all up and down this hill. Now, another thing to note here is that this metamorphic rock doesn't have a super strong, well-developed foliation. Where it does have a foliation, it's going, you know, roughly, I guess that's west-northwest is basically its strike, and subvertical, maybe in this case it's dipping back into the hill steeply. And so here's the Granite again, which again has typically has a magmatic foliation in it that's parallel to that. But if we actually trace out the contact, although the foliation in these two are subparallel, the actual contact is not parallel to that. So here we can see this is actually in place. This is in place. It wraps up around here. Those boulders are all in place. Here we can see a little apophysis of the wall rock sticking out into the granodiorite surrounded by it. So here all the foliations are parallel, but the contact on this hill goes basically perpendicular to that. Here you can see it coming up this way here, granodiorite here, metamorphics on the left. So it zigzags up this hill, sort of perpendicular to the foliation in both the wall rocks. Here you can see some of where the foliation is fairly well expressed, and the magmatic foliation in the granodiorite is also roughly parallel to that. Now, if you look at this on a zoomed out geologic map or whatever, this foliation is parallel to the you know, multiple kilometer scale outer contact of the Sahwave batholith. So it seems that this foliation was probably formed in response to a, you know, more maybe not quite regional, but a batholith scale stresses from the emplacement of the batholith. And so, let us say, if we look at the foliations here in the metamorphic rocks and the granodiorite, it's basically parallel to what it is over there in Juniper Pass, and that's the you know, the map scale trend of the contact is going more in this north-northwest direction, even though locally the contact is trending northeast. So, you know, I guess the story would be that this is a contact that, or so there's a foliation that probably developed due to more regional stresses, and then stoping has played a role in breaking off chunks and giving it this very irregular contact at the outcrop scale. Your view from up on top here. First of all, nice panorama. See Bluewing Flat there, Selenite Range, Lake Range. You're a little higher, you can see the Nightingale Range better back there behind this foreground hill. Sahwave Range, Northern Sahwave Range, Juniper Pass. And so you can almost just see where the northern contact is of the Sahwave granodiorite in that mountain. You can just see at the very left edge of that far ridge that it gets a little bit reddish colored. So the contact goes through there and basically comes through here, and then goes out that way somewhere, and then disappears into the plain for a while. And so that regional trend is basically the parallel direction that this foliation in the country rock is going here. But again, locally, this foliation is truncated by the contact that's coming around here and then going around that way. That's clearly cutting across the direction that this foliation is going. Now, that said, all of the foliation that's striking in this more east-west direction is then actually cut off, this foliation next to the Pluton is actually cutting across an older foliation in the main part of Bluewing Mountains. So I've now changed my camera directions, but the local foliation is basically going perpendicular to our look direction here. But if we go up into that ridge, it's maybe a little hard to see, but there are layers of rock that are basically come down parallel to that ridge. So the regional foliation is more northeast trending, and that northeast trending foliation is cut by this west-northwest foliation near the batholith. And basically we lose the batholith parallel foliation by the time we get to the bottom of that valley. That hill over there is already in the stuff that's striking northeast. So it's you know, it's 100 or 200 meters of structural oriel only. I don't think I'm going to walk over there though right now. Kind of cold and windy.